Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be starting with the new continuous random variable distribution, which is exponential distribution. We'll discuss some of its properties and we'll be doing some questions on that. Exponential distributions are of two kinds. One is one parameter distribution and the other is two parameter exponential distribution. Today we'll be discussing about one parameter exponential distribution. If there is a continuous random variable x which follows exponential distribution with the parameter theta, then its PDF can be defined as fx is equals to theta e raised to the power minus theta x, where both the theta and x are greater than 0. Take value greater than 0. This term is known as the PDF of our exponential distribution. If x follows exponential 1 upon theta, then PDF is written as 1 upon theta exponential minus x upon theta. And here also theta and x both have greater than 0 values. So this forms the PDF of our exponential distribution with one parameter. Now talking about its properties, there are some of the important properties of exponential distribution. The first property is mean only. We are talking about x follows exponential theta, the one which I encircled. So the mean of exponential theta is 1 upon theta. And if we talk about variance of this distribution, then it is variance of x will be 1 upon theta square. Here mean is not equal to median, so median has its own formula, which is 1 upon theta log 2. This is the formula for median. Now there are one or two properties also on MGF. If we talk about the force property, which is MGF, moment generating function, then for exponential distribution, moment generating function is denoted as mxt is equals to 1 minus t raised to the power t upon theta raised to the power minus 1, which is, we can also write it as 1 upon 1 minus t upon theta, this. And the fifth property is that sum of n IID variables follow gamma distribution. This is an important concept. Sum of all IID. If we sum all the IID exponential distribution variables. If we sum all the exponential variables, suppose this is x that has been given to us. Suppose there is a family of x, x1, x2, x3 up till xn, all follows exponential theta 1, theta 2, theta n respectively. And when we sum all of them, then that distribution will be of gamma distribution. So these were the important properties of our distribution. Now let us move forward to another question. Let us start with question. Here in this question, they have given us that 4 statements and they have asked us about the exponential expectation and variance. Expectation is nothing but expectation of x is nothing but mean, and v of x is nothing but variance. Now we have been provided with an exponential distribution. So they have given us fx theta is equals to theta e raised to the power minus theta x, where x is greater than 0 and theta also is greater than 0. Now we know that from the formula mean or expectation of x is 1 upon theta and variance of x is 1 upon theta square, and they have given us variable values of theta. If suppose, let us take, if theta is equal to 2, which is greater than 1, if we are taking theta equal to 2, expectation of x will be 1 upon 2, which is zero point 0.5, and variance of x will be 1 upon 2 square, which is 4, which will be 0.25. Clearly from these two we can see that expectation of x is greater than variance of x, which is 0.25. So for theta greater than 1, expectation of x or mean of x is greater than variance of x. So here the second term states that for theta greater than 1, expectation of x is greater than variance of x. Now suppose if we have to find for theta belongs to 0, theta lies between 0 and 1. Suppose we are taking the value of theta as 0.5. It lies between 0 and 1. So if we put it in the values, expectation of x is equals to 1 upon theta. If we put 1 upon 0.5, it will give us 2. And if we put variance is nothing but 1 upon theta square, which is nothing but 1 upon 0.25, which will give us 4. Here we can clearly see that 2 is less than 4, which means that expectation of x is less than variance of x. So for theta lies between 0 and 1, expectation of x is is less than variance of x. So both the statements A and B are correct in this question. Now moving forward to another question. Here they have given us, this question will be solving with two patterns so that you know how to solve it in exam if any of them comes. So we have been provided with x is a random variable which follows exponential theta, and they have asked us to calculate expectation of x square. Now we know that expectation or we know that variance of x is nothing but expectation of x square minus expectation of x whole square. This is the formula that we did. So variance of x, if x follows exponential distribution, then variance of x is 1 upon theta square, and expectation of x square we have to find. Expectation of x, which is the mean, will be equal to 1 upon theta whole square. So expectation of x square will be equal to 1 upon theta square comes this side, it will be 1 upon theta square plus 1 upon theta whole square. I can write it as 1 upon theta square only, which will give us 2 upon theta square. So our answer would be option number C, 2 upon theta square. This is one kind. Another method that we can use, method 2. This is method 1. Another method that we can use to calculate this is expectation of x square. If we solve it by expectation formula, then you know that x lies between 0 and infinity. So we'll put 0 and infinity fx. Fx is theta into e raised to the power minus theta x into the expectation we are calculating for x square. So x square dx. Now here theta will come outside. It acts as a constant 0 to infinity x square e raised to the power minus theta x dx. From here we can see that this is nothing but a gamma distribution, gamma integral, and the solution for this is theta will be outside 1 into gamma of 3 upon theta square. So now here theta cube. So now here gamma of 3, if we talk about gamma of 3, it will be 2 factorial. 2 factorial means 2 into 1, which I can write as 2 only, upon theta cube. So cutting this, cube will get cancelled to square, so it will be 2 upon theta square again. Now if we talk about gamma integral, if we integrate 0 to infinity, x raised to the power n e raised to the power minus theta x dx, then if we integrate this, then our answer will be gamma of n plus 1 upon theta raised to the power n plus 1. This will be doing in gamma distribution as well. For now, you can see this term. How do we solve that? So these are the two methods that we can use to solve this question. Now moving forward, this question has been provided to us where exponential x follows exponential lambda. Here instead of theta they have given us lambda, and they have given us the probability that probability x is less than equal to 1 is equal to probability that x is greater than 1, and they have asked us to find variance of x. From here also we will solve the probability first. Probability that x is less than equal to 1 should be equal to this greater than 1. I can write it as 1 minus probability x is less than equal to 1. Since these two terms are same, we can take it on one side and they'll be get added. It will be 2 into probability x less than equal to 1 is equals to 1. Probability that x is less than equal to 1 is equals to 1 by 2. Now x lies between, we know that for exponential distribution, x is greater than 0. So here we can open this probability. The limits will be from 0 to 1 fx. Fx is nothing but lambda e raised to the power minus lambda x dx is equals to 1 by 2. This is how we solve it. So on solving it, we'll be getting our value for lambda. If we let us solve this, lambda will be taken outside. E raised to the power minus lambda x integration will form e raised to the power minus lambda x upon minus lambda with the limits 0 and 1 is equals to half. Now here this lambda and this lambda gets cancelled, and if we put the limits, e raised to the power minus 1 will be 1 only. Will minus 1 into lambda will be e raised to the power minus lambda, and if we put the limits, e raised to the power minus lambda into 0, it will be e raised to the power 0 with the minus sign outside, and this will be 1 upon 2. This will be nothing but e raised to the power 0 is nothing but 0 1 only, right? And if we take minus sign that side, so it will be e raised to the power minus infinity. Taking minus sign on other side, yes, taking minus sign on the other side, it will be 1 minus e raised to the power minus lambda is equals to 1 by 2. Now 1 by 2 can be taken this side and e raised to the power minus lambda this side. 1 minus 1 by 2 will be 1 by 2 only, and if we take log on both sides, it will be minus lambda is equals to log of half. Log of half can be written as log of 1 minus log of 2, which can be written as log of 2. Now this minus minus gets cancelled and we have the value of lambda as log of Now they have asked us about the variance. If we talk about the variance of the variable is 1 upon lambda square. Lambda has the value log of 2. So 1 upon log of 2 whole square. This forms our answer as option number A. Now moving forward to another question. This is a statement question in which they have asked us that the increase in sales in a shop per day after the appointment of a new sales girl is approximately exponentially distributed with mean 3. So we have been given the value of theta as 3. The probability of getting an increase of over 9 units. They have asked us the probability of getting an increase of over 9 units. Now we can write it as 1 minus probability x is less than equal to 9, because we know the lower limit, which is here exponential distribution has lower limit of x and theta as 0. They cannot be less than 0. So we'll take minus probability x is less than equal to 9. So if we have to talk about probability x is less than equal to 9, then this will be integration 0 to 9 with fx. Fx is theta e raised to the power minus theta x dx. And if we solve this, we'll be getting theta e raised to the power minus theta x upon theta with the minus sign with the limit 0 and 9. On solving it, theta and theta will get cancelled, and e raised to the power minus theta x, if we talk about them, then it will be 1 minus e raised to the power minus 9x, 9 theta. This will be our limits for this. Now here they have provided us that theta is nothing but equal to 3. If we have to solve this, it will be if we have to put in probability x is greater than 9, it will be 1 minus probability x is less than equal to 9. Then this will be 1 minus e raised to the power minus 9x, which on cancelling will give us e raised to the power minus 9. Over 9 minutes. Probability. Here one more thing is there, that 1 upon 3 is the value of 1 upon theta, because they have given us mean is equals to 3. Now mean has the formula 1 upon theta, so here 1 upon theta is 3. So instead of writing theta here, we can directly write uh, the quantity of theta, which is 9 into theta, is equal to 9 by 3, which is equals to 3. So here if we put it equals to e raised to the power minus 3, we'll be getting our answer as minus 3, e raised to the power minus 3, which forms our option number B. Now moving forward to our last question. Here also they have provided us the PDF of exponential distribution, and they have asked us to calculate what will be the distribution of y is equals to e raised to the power lambda x. Now they have provided us, they have given us y is equals to e raised to the power minus theta x. If we differentiate y with respect to x, then we'll be getting e raised to the power minus theta x into minus theta. This we have got. If we have to change the distribution of one variable into the second, then the formula for that distribution is g of y is equals to f of x into modulus of dx upon dy. Right? This has the changing formula. So g of y, which is the distribution of y, sorry, fx has been given to us theta e raised to the power minus x theta, and 1 upon, what have we calculated dy by dx? It will be 1 upon minus theta e raised to the power minus theta x with a modulus sign. Then here if we see that when it comes out of modulus, there will be no negative sign, so this denominator and this numerator will get cancelled and we'll be getting the distribution of y as 1. Now which one satisfies? If we talk about first option, which is uniform distribution with the limits 1 and 2, it does not satisfy it, because if it only has one parameter, which is 1. So these two do not satisfy it. If we talk about uniform distribution 0 and 1, yes, it can satisfy, because fx will be 1 upon b minus a, and b minus a is 1 upon 0, which is 1, which satisfy this one. So our option B is the correct. And if we talk about normal distribution, then fx of normal distribution having mean 0 and variance 1 should be 1 upon sigma is 1 root 2 pi exponential minus 1 upon 2 x minus mu, x is cancelled, and sigma square. So this must be the distribution of standard normal distribution, which is also not the case. This and this are not equal, and hence our option B is correct and option D is wrong. So this was all about exponential distribution. I hope that you got whatever we have done today in class, and if you have any doubts, then you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.